Welcome to this TSAS Tech Talk regarding dwelling unit load addition.
In today's day, it is common for people to want or need equipment which their older home's electrical service was never sized to accommodate. Equipment such as hot tubs, electric vehicle chargers, and even air conditioners can be too much load for older houses with smaller services. If someone is planning to have any new equipment added to their home, it is important to ensure the service size is adequate for the load or loads being installed. Electrical inspections will be thorough in verifying that services are not overloaded. The reference which inspectors, and ultimately homeowners or their contractors, should utilize to ensure adequate service size is the Canadian Electrical Code, specifically Rule 8200. 8200 can be followed rule by rule to establish the proper size of electrical service required based on size of home, loads that are currently connected, and loads to be connected. One will need to know their interior dimensions of their home on all floors. They will also need to know the wattage load of all major appliances connected in the home. Finally, they will need to know the wattage load of the equipment they wish to add. Let's have a brief rundown of 8200 and reinforce it with a real-life scenario. We see that 8200 is used to obtain the size of a service or feeder for a single dwelling unit. Take note that it is a calculated load and is greater of either Subrule A or B. Subrule A is a watts calculation based on the living area and the loads in the house. Lots of equipment is marked in volts and max amps, so don't forget watts is volts times amps. Subrule B is a predetermined minimum watt size based solely on floor area of the home, excluding basement. Let's talk about Subrule B first, as this allows us to establish our absolute minimum service size based on home square footage. 8200B Subrule 1 says that if a house is larger than 80 square meters, or 861 square feet, its minimum service size must be 24,000 watts, or 100 amps, right? 24,000 watts divided by 240 volts is 100 amps. 8200B Subrule 2 says if a house is smaller than 80 square meters, or less than 861 square feet, its minimum service size must be 14,400 watts, or 60 amps. Make note that floor area excludes the basement for 8201B. Now, just because the house's current service might meet the minimums, that doesn't mean that the service will be large enough to add new equipment. In fact, there is a real possibility that due to the equipment connected already, there may not be room for any new loads. Let's start our example. A typical 1.5-story home with a realtor listing of 980 square feet would be 36 square meters on the top floor, 55 square meters on the main floor, and a basement of about 54 square meters. Don't forget that the floor area for 8201B excludes the basement. We are noting the basement size now because we will be needing it later. So the total floor area of this house would be 91 meters squared, and as per 8201B2 from before, since it is more than 80 square meters, the calculated service load is 24,000 watts, which, when divided by 120 volts, works out to 100 amp service minimum required. But that's not the end of this example, because we have to see if a calculation through 8201A will require this home to have a service that is larger than the 100 amps required by 1B. Now, we will jump back and discuss 8200 Subrule 1A. It starts with parts 1 and 2, and they are establishing a base load for the size of the house. Part 1 is looking to establish 5,000 watts of base load for the first 90 square meters, or 969 square feet, of living area. Part 2 goes on to add 1,000 watts of base load for each successive 90 square meters or part of 90 square meters of living area. But now you're asking, how do you know the living area? Good question. To get to that, we need to go to CEC Rule 8110. CEC Rule 8110 lays out how to calculate the living area of the dwelling unit for the purposes of 8200. 8110 says to use inside dimensions and add up 100% of the ground floor area, 100% of areas above ground floor used for living purposes, and 75% of the area of any floors below the ground floor. It is worth mentioning that in 2024, a clarification to exclude crawl spaces from the living area will occur, and only if the walls are greater than 1.8 meters high will the space be considered as living area. Going back to the example we started before, and the 980 square foot house, remember, those 980 square feet are about 91-ish square meters, and would be 36 square meters on the top floor, 55 square meters on the main floor, and a basement of about 54 square meters. 100% of 55 plus 100% of 36 plus 75% of 54 comes out to 131.5 square meters of total living area. Now let's bring that 8110 example into our 8200 1A, 1 and 2. Our 1.5 story house from before had a calculated living area of 131.5 meters square. From that, we assigned 5,000 watts for the first 90 meters squared, and the remaining 41.5 meters gets assigned 1,000 watts. Moving on to 8200 1A3 and electric heating and air conditioning load. Electric heating loads get put into service calculations, but only with applicable demand factors ascertained from Section 62 of the CEC. Demand factors will be based on what type of electric heating is installed, as in electric furnace versus baseboard heat. Air conditioner loads are put into service calculations at 100% of their rated full load amps. Now, one thing to be cognizant of is if the electric heating and the air conditioning are interlocked, so only one can run at any specific time. If they are interlocked, then only the larger load gets put into the service calculation, not both. In our example, the 1.5 story house has the typical gas furnace, so there is no electric heating load, but it does have a 1.5 ton air conditioner. The AC has 10 amp max load, which at 240 volts means 2400 watts for our load calculation. Moving on to 8200 1A4 and electric range load. The rule for electric ranges requires 6,000 watts for provision of any electric range up to 12,000 watts, which is 50 amps by calculation, and is the typical receptacle located in most residential kitchens. If there happens to be specialty equipment and a range rated at more than 50 amps, then any load over 50 amps or 12,000 watts must be taken at 40%. Our example house, with its typical range receptacle, is taken as a 50 amp load and gets 6,000 watts for the calculation. When we get to 8200 1A5, we start looking at tankless water heaters and water heaters for pools, hot tubs, and the like. Water heating load is taken at 100% of the nameplate rating. Our same 1.5 story home happens to have a 6-man hot tub in the backyard, and his rated max load is 50 amps. At 240 volts, that's another 12,000 watts for the calculation. In 8200 1A6, electric vehicle charging loads are considered. All electric vehicle charging must be taken at 100% demand factor unless there is an energy management system installed that monitors the service load and controls the amount of draw by the electric vehicle charging circuit. If such a system is installed, then electric vehicle charging doesn't need to be considered at all, as in no watts needed to count to the service calculation. In our example, our 1.5 story house has no EV charging, yet. Finally, 8200 1A7, all other major electrical loads. Calculating the remaining major electrical loads is a bit tricky. First off, other major electrical loads are considered to be any load greater than 1500 watts that haven't already been accounted for in the overall equation. Greater than 1500 watts means loads larger than 12.5 amps if they are 120 volts, and 6.25 amps if they are 240 volts. Equipment like the air conditioner and primary electric range have already been covered in the overall calculation and would not be part of Subrule 7, but things like electric clothes dryers and a second electric range would. Second, the calculation has two possible options, dependent on if an electric range is already part of the overall service calculation or not. If an electric range has been put into the overall calculation already, then each major load shall be taken at 25% of its rated load. If there is no electric range, then the major loads ratings are combined and put into the calculation at 100% for the first 6,000 watts and at 25% for the remainder that is over 6,000 watts. Now, our example home happens to have a monster central vacuum and an electric clothes dryer. The cyclonic central vac is rated at 15.8 amps at 120 volts. That's an 1896 amp load, taken at 25%, equaling 474 watts. The electric dryer is 30 amps at 240 volts, a 7200 watt load, which at 25% is 1800 watts. 474 plus 1800 is 2274 watts for our calculation. That's all the parts to the calculation, so let's review what we have in our example. Our Part 1 basic living area was 5,000 watts. Our Part 2 additional living area load was 1,000 watts. Part 3's electric heat, and in our case air conditioning load, was 2,400 watts. Part 4's electric range load was the basic 6,000 watts. Part 5, the specific water heating, was 12,000 watts. Part 6, the electric vehicle charging load, was non-existent. And finally, Part 7 and the other electrical loads came in at 2,274 watts. That's a grand total of 28,674 watts. Let's look at the service requirements for 8200 1A and 1B. 1A's 28,674 watts divided by 240 volts is 119.475 amps, meaning a 125 amp service is required. 1B's floor area calculated load of 24,000 amps divided by 240 volts is only 100 amps. Now remember, 8201 requires us to take the larger of A and B. So A's calculated 125 amp service is the minimum service size allowed. Good thing this house had 125 amp service installed when the hot tub was added 10 years ago. So, with our running example, can a homeowner install a level 2 car charger? No way. In fact, even if this house had 150 amp service, there is a strong likelihood a size increase is required, as most level 2 electric vehicle chargers require more than 25 amps at 230 volts. That said, there is one option available to be able to get electric vehicle charging into this house. If an electric vehicle energy management system is installed, specifically one that complies with CEC 8-10611, then the EV charger load need not be included in the service calculation. There you have it, a step-by-step run-through of calculating a service load. We've highlighted the importance of performing a service calculation when you are faced with adding a major load to a dwelling unit. It doesn't take much to be over the line. Make sure the due diligence is complete before the install. Better safe than sorry. That's all for now. Hope you found this TSASK Tech Talk informative. Have a great and safe day.